Hi, everyone. Thank you so much for joining us. I know it's been quite a long day already. We're in the middle of the afternoon, so I have the privilege of trying to get everyone attention back to the webinar again. So I hope everyone's comfortable. If you need a drink, please feel free to grab some. I'll be starting off a bit slow. So I have a couple of slides, but I promise not to have too many. Okay, so just to give you a heads up, I have about 15 slides, okay, including this slide, the agenda, and the thank you page. So that means I have 12 slides of content. Other than that, I've got quite an action-packed series of videos and also a demo to show you. My topic today will be on public cloud agility for load balancing, right? So the idea is that when we do load balancing, the traditional way of doing it is to have physical boxes, right? And these are deployed in our data centers. But now with a lot of our customers, going to the cloud, how do we rethink the way that we do application delivery, right? How do we do WEF? How do we do things like GSLB, right? So that's some of the topics that I'll be covering for today. Okay, so to briefly run through with my agenda, I'll be starting off with what does it mean, right, to perform load balancing in an agile manner. And then I'll go into why traditional application delivery controllers, or ADCs, right, they could be a potential roadblock for you in your digital transformation initiatives. And then we'll go into what it means to have a cloud-ready architecture, right? How do you produce a load balancing framework that is consistent and automated across your different environments from on-prem to the cloud? And then I'll be going into some of the customer success stories. I've got a nice interview that we've done with a global partner. And then I'll share with you some key takeaways to end off, all right? Also with a demo to show you what we can actually do with the agile load balancing solution. So to start off, right, I want to share with you one of the conversations I've had with a particular customer, and he was looking at deploying new applications in his application portfolio to cater to his business needs, right? And these are some of the questions that he's been asking me, because at that point of time, he did not have any load balancer, and yet his development team is coming up with new applications, and he's been tasked with choosing a suitable load balancing solution for his needs. So these are some of the questions he's asked me, right? One of them is, right, how do I provision new virtual services, right? A virtual service refers to a load balancing service. So one of the applications that you need to load balance, for example, it could be your app server that's a web server that's front end facing. So he's asking how can he provision one easily, because he knows that to stitch together this load balancing architecture, there's various steps to take. You have to register the IP address on your DNS. You have to connect that to your backend app servers or DBs, and this takes a lot of time. Another question is, how does he perform troubleshooting if the app team face issues, right? Because you would definitely want to resolve issues quickly as and when they happen. How do I scale my load balancers, right? If I have limited capacity, or if I run out of capacity using my existing appliances, is it easy to scale, right? He also had an initiative to migrate to the public cloud. So how do I migrate my apps to the public cloud without having to make significant changes to the way my application runs and how traffic going to the application is being load balanced? And most of all, lifecycle management is something that takes up quite a lot of time and resource, and we would want to make sure that upgrading these load balancers is something that's as easy as a few clicks, right? So going into why we need to perform a transformation in the way that we deliver applications, right? The demands on us as IT folks to our companies is ever increasing. We are tasked to increase the time to market, we need to modernize our applications using new application frameworks or architectures, right? Migrating to microservices, using platform as a service like Kubernetes and so on. And we want to make sure that we do it at the most cost-efficient manner. And yet, at the same time, from the IT standpoint, we've got a larger portfolio of applications to manage. There's so many changes that are happening to these applications that our IT teams are essentially overloaded already. And we've got a lot of legacy environments, or we have some technical debts that we have to deal with in order to make these changes happen, right? So in order to address these, VMware has already provided a set of software-defined frameworks. We have the software-defined compute with vSphere. We help to virtualize your storage with vSAN, and we've even taken care of the network piece as well. We have NSX, and you can see that to my top right. So the next thing that we need to address is the load balancers, because this is the front end facing part of the application, right? How do your applications actually face the web, and how do they manage the traffic that's coming in and distributing that across your various web or app servers? So the challenges when it comes to implementing load balancing is that it tends to be not very scalable, right? So traditional load balancing tools tend to be physical or appliance based, and this means that you can't scale beyond these physical limitations. It tends to be not so agile because you can't easily set up your applications in such a way that's automated, right? And it's not very flexible because if you are using a physical appliance, then definitely this is not something that you can use in the cloud. You would have to use something else, maybe the native cloud load balancer, or you could look into other software-defined load balancers that are multi-cloud in nature, right? And that's what we are going into today. So diving a bit deeper into what are the challenges using traditional application delivery controllers or ADCs, right? They tend not to be built for cloud because, as mentioned, they tend to come in physical boxes in an active standby pair. So in this case, for example, you might have one box that's used to a 15% capacity, and the other box, because it's purely for standby, for failover purposes, right? You essentially are using 0% of the investment that you've made into that piece of hardware. And as your applications scale, right, you might need to have a set of load balancers in your DMZ. You might need a set of load balancers in your internal environment. You might need multiple pairs of load balancers to cater for different applications. And when that's the case, right, you have dedicated load balancers for specific applications. And as we all know, not all applications has the same amount of traffic going through them. So in the case that a single pair of load balancers, they have met their capacity, for example, the one in red, you might have 80% capacity, you can't essentially pull together that capacity from the other load balancers because the load balancers are tied to the physical hardware itself. You can't aggregate the resource across these physical load balancers. At the same time, each pair of load balancers act as a single unit of management. So whatever you have to do for a single load balancers pair, you would have to replicate that across the other load balancers in the case that if I want to do a software upgrade or I want to make a certain configuration change due to security settings and so on. So you can see that easily the complexity doubles and quadruples as you go along. Also, with these multiple points of management, there tends to be issues with troubleshooting because whenever something happens, like let's say your end user is facing performance issues with the application, then the app owners will point to the network team saying it's a network issue, and the network team will point it back to the app owners. So without having sufficient visibility, right, and centralized management into your application delivery, easily it could take you days to even resolve some of these issues. And yet at the same time, I've mentioned that if these load balancers are going to be physical in nature, right, you won't be able to deploy this in the public cloud because there's nothing physical there that you can manage on your own, right? So you would need something that's software defined, right? That sits as a virtual machine in a virtual environment, such as your on-prem vSphere or your maybe native EC2 in the cloud, right? You can deploy it there, and essentially you can create a load balancing fabric, right? Wherever your applications are sitting. And I would like to introduce the concept of a control plane and data plane as well. You can see over here. So what we've done with our software-defined load balancer is that instead of having the control plane and data plane seated together in the same appliance, right? What you're going to see is that we have actually separated that out, right? So I'll go into the components in just a moment. And at this point, I would also like to discuss what it means to deploy load balancers in the public cloud, right? So on the left here, I've already briefly touched upon what it means to run the traditional setup where you have a dedicated load balancer appliance. And in this case, it gives you the enterprise features, right? These boxes are meant to be physical for a reason, because they have been pre-configured, they're proprietary, they've got all the enterprise features that you need, right, to protect against DDoS, and they have additional security features, WAF, and all that. But on the other hand, right, if you look at the cloud provider load balancers, such as those that are made available natively on Azure and AWS, right, they tend to be lacking in certain enterprise features, right, because they were they were created just for the sake of providing basic load balancing services in the cloud. So how do I combine the best of both worlds, where I have the flexibility of deploying my load balancer to any environment, whether on-prem, in the cloud, and yet making sure that I have those enterprise features to enhance my security posture and to increase automation and ease of management of my load balancing fabric? So this is where I go into the key characteristics, right, that we want to focus on when we determine how we want our applications to be delivered, right? We want to make sure that, first of all, that there's a lot of automation in place, right? We want to free our IT folks from having to do a lot of those manual configurations and changes and software upgrades. We want it to be elastic, right? If there's any resource contention, we want the load balancing solution to be able to scale on demand and in a way that is of little IT touch. Maybe you could implement an approval process, or maybe you could just let the load balancer scale out on its own, or even scale up in the resources. It's very flexible in that manner. And at the same time, you want to make sure that there's sufficient observability in such a way that when there's any issues happening in the environment, I have the dashboards, I have the graphs in place that I can easily troubleshoot and slice and dice the data in such a way that I can pinpoint the issue easily. So this is where I will introduce the load balancing solution. So this is coming from VMware. The name for it would be NSX Advanced Load Balancer. So that would be NSX Alb for short. And it actually came out of an acquisition, right, of RV Networks. So RV has been rebranded into NSX Alb. And this is where I'm going to introduce to you the architecture of the solution itself. So as I've mentioned briefly earlier, instead of combining the control and data planes into the actual appliances, what we have done here is that we have separated it out. Okay, we have a controller-based architecture where the the controllers themselves are deployed as a set of virtual machines, and so are the load balancers. Right, in this case, instead of load balancers, I will call them service engines. Okay, so this is a RV terminology. And with the service engines deployed into the environments that they need to, for example, I can have a pair of service engines in my DMZ, I can have a pair in the internal environment, I can have another pair in the test and dev environment. And all these service engines, they can be deployed to any environment, whether it's on your on-prem vSphere, in the public cloud, on AWS, on Azure, right? or even to cater to different types of workloads, right? You can load balance your workloads sitting in bare metal environments. You can cater to your virtualized workloads, right? You can even cater to containers, right? So one of the cool features of RV is that it can act as an ingress controller as well, right? For your Kubernetes-based applications. So the idea behind this is that we can give you central orchestration because everything is managed by the same set of controllers that you have deployed, right? It's a single pane of glass. You get the elasticity because you can put in place policies in such a way that when there's a resource contention, then you can easily scale up the number of service engines you want to deploy for that virtual service. There's more resilience because in the case that any load balancer goes down, you can easily just take it down and then spin up another virtual machine because all these are existing in the virtual world. There's nothing that's based on the physical hardware itself. And you can implement automation, right? So I will go into detail a little bit more in my next slide, showing you what are the considerations that RV can handle for you out of the box, right? Where you don't have to actually configure this individually on your own. And ultimately, it also gives you observability and analytics, right? So I won't really explain so much here. I want to show it to you instead during my demo later. Right, finally, we have Pulse services, right? So Pulse services is basically a SaaS service that helps you with your signature updates because RV itself can perform web application firewall to protect you against DDoS attacks or slow lorries and other attacks as well. Okay, so looking into some of the capabilities, right, coming from NSX ALB. So this provides you with a more comprehensive view into what exactly can RV provide, right? So in this case, starting from the left, if you have an on-prem vSphere environment, for example, right? RV is integrated directly into NSX. That's why it's called NSX ALB. So if you actually purchase NSX, right, you will actually get a basic edition of the NSX ALB coming together with your NSX purchase. It also comes together with VCF. So that's a bit of a repeat because VCF itself includes NSX. It's integrated into vCenter, right, in such a way that using this integration with vCenter, that's how a lot of the automation happens because RV automatically detects the underlying networks and creates the virtual machines by pushing these OVAs directly to vCenter itself. It can also integrate into bare metal and OpenStack environments, like I've mentioned earlier. So for the rest, I won't touch into so much detail, right? I've only got a little bit of amount of time, and I mentioned that this is going to be a very action-packed session for you, right? Hoping that this will be something that's interesting as well. So in my next slide, I will actually be going into a customer interview that was performed during our recent VMware that happened earlier this month. Okay, so without further ado, I will go into the customer case study.
And William, welcome to the conversation with us. And William joins us from LogMeIn. He is Senior Director of Global Infrastructure at LogMeIn. His team is responsible for providing infrastructure as a service, core services, and global networking solutions across LogMeIn's 24 on-prem data centers and public clouds, and supporting LogMeIn products such as GoToMeeting, GoToWebinar, GoToTraining, LastPass, and LogMeIn Central. William brings over 20 years of extensive experience in managing mission-critical infrastructure and providing technical and operational leadership for large-scale global organizations. He also spent time at Intuit, where he led the global infrastructure teams there as well. William holds a BS in computer engineering degree from the University of California at San Diego. Welcome, William. And what I'd like to do is just quickly start with a description of your application environment.
Yeah, thank you, Chandra.
If you can go to the next slide.
Go to the next slide. Yeah, thank you for having me join this session. And LogMeIn has 3 pillars of product groups. which my global infrastructure services team supports. Unified communication and collaboration has all the go-to family of the products, handling meetings, events, and contact center needs. In the middle section, we have the remote solutions group, helping with the remote desktop and all the endpoint management. And lastly, the LastPass, which handles the identity provider and password management. And our hosting environment ranges from the traditional bare metal systems, OpenStack, Kubernetes, and multiple public clouds like AWS, Azure, OCI, and we leverage GCP as well. And we have to support the internal customers ranging from submit a ticket and you do everything for me to the customers who just want the API access and they will do everything themselves, integrating with Terraform, etc.
So William, tell us a little bit about the application delivery challenges that you were looking to solve as you supported your internal customers. Yeah,
there are several things that that we have challenged with. The first one is the speed of the delivery. With the traditional load balancers, our DevOps teams submit tickets to Jira and get approved, then my network engineers have to implement it. It typically takes about 48 hours to a week for each of the requests. And also scaling isn't easy. Traditional load balancer setup is always an active standby pair, and scaling requires us to buy bigger boxes, scheduling the downtime window, maintenance windows with our customers and get them installed. And coordination on the downtime is a nightmare because of the amount of teams that we have to coordinate with. And also traditional load balancers, when we are doing the patching upgrade process, and also requires downtime with many of our products going down together at the same time, right? And lastly, the visibility portion. During any of the incidents troubleshooting, we don't have much visibility through the traditional load balancers offerings. And oftentimes we have to log into the APM solutions to see what's going on the app layer, response time, and narrow down the problem area.
Got it. Now, tell me a little bit about, how you went about solving for these challenges. How did Avi help in this whole transition? And, what were you able to see as a result of deploying Avi in your environment?
Yeah, let me just give the team one example, right? During the COVID time in 2019, our traffic spiked up to about 10-fold. And one of the important pieces of our infrastructure is to support our GoToMeeting product client downloads, and using our internally developed CDN solution, which is based on Varnish running on OpenStack environment and front-ended by the Avi load balancers in multiple regions around the world. And Avi helped us dynamically grow the capacity on demand, and we spin up more service engines instead of buying and swapping bigger physical load balancer appliances. And we don't need to schedule the downtime to do this scaling up event and scaling sideways, right? And while we're seeing our competitors showing up on the down detectors, we're able to keep up with the demand, right? And also the building visibility also help us to understand where are the system hotspots that help us proactively to address application side of the problem, the congestions, right? Spreading the load across more systems and taking out the problem node quickly. Right? Overall, we're very happy with the partnership with VMware, and we're looking forward to the continued success.
Fantastic. Thank you very much, William. That's a neat walkthrough of your environment. It sounds like a very high SLAs that you have to maintain with your internal customers. And thanks again for coming and joining us and describing your use case for Avi on the call.
Okay, so that was the case study for Log Me In. And now I will be touching on one other case study that I have. So this is one of my customers in the Philippines, because for me, if you've heard, right, I don't actually have a Filipino accent. So I'm actually based here in Singapore and I'm serving the Philippines market. So one of my recent customers for Avi is listed here as follows. I won't be sharing the name, of course, but I just wanted to describe to you the challenge that they had and how we went about solving it. Okay, so in this case, for this customer, their challenge was that their existing load balancer solution at the time did not meet their multi-cloud needs, right? So this customer, they had AWS workloads, they had Azure workloads, and they had existing load balancers that were only catered to their on-prem environment, right? And these were, of course, physical boxes. And in this case, they didn't want to have to use a different load balancer solution in the public cloud, because that would mean separate points of control, increased complexity, increased number of skill sets that they will need to develop. And with what they had at the time, the amount of integration into the public cloud was limited, right? So this means that on an overall perspective, the scalability and availability of their load balancing architecture was still limited. So in this case, what we proposed to them was to use a solution that is software defined, right? That's integrated into their existing hypervisor itself, which is none other than vSphere, and also with what they have existing in the public cloud environment, right? So if it's on AWS, then it's EC2, right? And they wanted to use it in such a way that's centralized, so that using the same control plane, right, deploy the load balancer instances to whichever environment that they need to deliver applications. And at the same time, they wanted to have that analytics, right, to have more visibility into the capacity, into the performance of the application, and to make troubleshooting a much easier process for their infra admins. So what we've done is that we implemented this NSX ALB, right, into different environments. We have some sitting in the DMZ environment for their web servers. We have some in the internal environment for their own internal load balancing requirements. And at the end of the day, what they stood to achieve was improved operational efficiencies, because when they deploy new virtual services for load balancing, right, it's a very much automated process. I will show you later during the demo how we can address all the individual configurations, like setting up the load balancer, tagging it with the IP address using IPAM configurations, registering it on a DNS automatically, right? And even scaling up and down dynamically, right? All this can be done without any infra admin overhead at all. It made this customer much more cloud ready, right? So they can deploy their applications to new public cloud environments as necessary. And at the same time, it gave them better visibility into the application performance itself. And this is going to be an aggregate score. So this is actually a study done by IDC. And these are some of the figures given to the, based on the survey, right, that was done on NSX ALB itself. So you can see that the ROI is quite incredible. Over 3 years, they stood to achieve close to 600% ROI. The cost of operations itself, right, was dramatically reduced, right? Where you can see here is about 47%. It also helped them to increase their application developer productivity, because a lot of the considerations that you have to take into account to making your application available to end users, right, is addressed for you automatically using the platform, and so on and so forth. Right? I won't go into each of them, just to show you the results that our customers stood to gain using this NSX ALB solution. And before I go into the demo, this is going to be my last slide, which is the key takeaways, right? The idea behind NSX ALB is really to automate as much as possible, so that this is one of the key roadblocks that you have automatically removed, right? By the time you want to deploy new applications, it can be taken care of very easily. The elasticity of it is very important, because as I've mentioned earlier, with traditional load balancers, the scalability of it is always an issue. In this case, if it's software defined, it's just as simple as spinning up new virtual machines, which all of us would know only takes a matter of minutes. And operations becomes much easier, because a really cool thing which everyone loves about NSX ALB is the visibility and the analytics, right? Which I'll show you in the demo I've prepared. Yep. So here you are looking into the NSX ALB UI, right? So this is accessed from one of the instances of the controller that I mentioned earlier, right? So by having a controller-based architecture, we have a single point of management for all the load balancing instances or service engines, right, that are deployed in the different environments. So you can see that the focus, right, of NSX ALB is on the application, right? It takes away a lot of the infrastructure headache when it comes to managing the load balancers itself. So what you see here are the virtual services that I have currently deployed. So currently I have 3 virtual services, right? In this case, all of them are being deployed on AWS itself, right? So if I show you the infrastructure, you can see that my default cloud here is hosted on AWS, right? So all 3 of these virtual services are being run on load balancers sitting on AWS itself. And from here, you can see that I have given a health score to each of these virtual services. So this health score it gives you an appreciation into how well this service is performing, right? And it breaks up the health into multiple components, right? Each of which will aggregate into the overall health score, as you can see here. So performance currently is performing at 93%, and it will be scaled back based on any of the penalties listed from the following, right? We have the resource penalty. If there's any contention with CPU, memory, or storage, it will show you that. Anomalies, right? Based on time-based data, it will show you if there's been any spikes along the way or any dips in performance, spikes in traffic or dips in performance along the way, and based on that, reduce the score accordingly. Then we have the security penalty. If we see that there's a DDoS attack happening, right? If someone is using unencrypted traffic, then it will also show you on the health score itself. So what we have here are 3 virtual services, and I'm just gonna deep dive into just one of them. In this case, right, just immediately clicking into the virtual service itself, you can see that what we do is that we break up the application response time into different components so that easily, right, from here, your network admin, right, if he's the one managing the load balancer, he will automatically see how much time, right, each hop is taking. So in this case, for the client to access the load balancer, right, the round trip time is 108 milliseconds. And in this case, this is the most significant component out of all the rest, right, where the total response time is at about 2 seconds. Okay, so I can see that from the load balancer to the server, which is internal, right, is very quick. It's just 7 milliseconds. The application itself takes about 45 milliseconds to respond, and the data transfer, right, it only takes about 35 milliseconds. So overall, a rather healthy service. But if, let's say, for example, I see a spike or I have an end user complaining to me of a performance issue, right? Maybe it's at about 9:30, close to 10 a.m. Then I can immediately deduce from here, right? Oh, okay, at about 10 a.m., I see that most of the latency that he's facing is coming from the application response time. Then I will be able to tell the app owner, hey, is something wrong with your code, right? Did you make any changes to your application that is causing it to respond in a slower manner? And this is something that gives us quick visibility. So a lot of times when there's an issue with the application performance, right, the application team will tend to blame the network team. And when the network team doesn't have sufficient visibility into these metrics, right, like the end-to-end timing, the throughput going through the load balance, going through the service, number of connections coming in, then they just tend to respond that, hey, you know, nothing's wrong. But actually, they don't have the visibility that they need to give a more informed answer. So in this case, just from this quick snapshot, right, the network team would be able to tell you, oh, actually, there's really nothing wrong. This is the amount of throughput. I have this amount of connections coming in, is completely being served well by the load balancer instances. And you can see that I've got various pools serving this virtual service. So these are pools of servers, right? So these are the web or the app server sitting behind the service itself, where it's being load balanced across. And you can see that all these pools are functioning at quite a healthy level. So in terms of logging, right, this is another key analytics feature You wouldn't get this with most other load balancing solutions, right? In this case, really the point here is to troubleshoot easily. So what we've done is that we've filtered all the logs into just those that are significant, and you can see that there's 140,000 of them. So how to dig into this further is by identifying a single log, right? Let's say I see this log and it's taking 200 milliseconds to respond, and this is quite significant, right? I want to know who's the one experiencing this. So it could be an end user telling me that, hey, this application is not performing well. I can filter based on the application, based on IP address, right? Or if it's that specific user, I can filter based on his IP address. And from here, you can see where he's accessing from, even what operating system he's using, right? He's using SSL TLS version 1.2 for encryption. I can see what are the servers that's serving his request, right? So this is the connection IP to the virtual server itself. I can see which is the service engine that's serving this request also. And I can see what's causing this significance, right? Why is this log being flagged up as a significant log? It's because of this high application response time. In this case, it's at 94 milliseconds round trip time out of the total of 135, right? And you can also see where he's trying to access as well. So it gives you information into the URL and the agent that's being used to access it. So in the case that I want to see all the logs that are above a certain amount of response time, so let's say I want to look at more than 200 milliseconds, then I can filter based on that, right? And from here, I will immediately see all the responses that's taking more than 200 milliseconds. And if I want to drill down on this data even further, right, I can slice and dice it based on, for example, what browser is accessing this virtual service, right? In this case, 40% of this set of logs is accessing via mobile Safari, right? More interestingly, if I want to know where this issue is coming from, right, I can try to dig into what are the servers that's serving this request, and I can see that, oh, actually I have 3 servers serving this virtual service, and out of these 3 servers, 100% of the logs is coming from this specific server. So the issue is lying with this server itself, right? And I can further click into the server to dig further for why the response could be taking so long, right? So this is an example of a troubleshooting methodology. And to, okay, I've got 10 minutes left or 5 minutes. Also to go into the virtual service itself, right? So in this case, you can see that deploying a new virtual service is actually pretty simple. There's a lot of considerations taken into account here. I have the address specified for this virtual service. I have the specific ports that I use, right? I can use a certain WAF policy. What cloud is being deployed on. In this case, is my default cloud, which is AWS. I can specify specific certificates, right? And I can look into the logs again here as well. And you can also see here, I have buttons to scale in or scale out the amount of resources I want to cater for this virtual service. Or I can even migrate this virtual service into another cloud altogether, right? So deploying a new virtual service is really simple. Right, I just need to specify the name, right? Basically, what I'm doing is to specify the intent of my application delivery, right? And RV will actually handle all the underlying infrastructure for me, right? It will take care of the registration on the DNS, right? Using the domains, right? It will take care of the IP address by integrating with your IPAM system. You can even choose the servers to load balance across from here. If there's an integration with AWS, right, then you can see the networks, and I can choose the network and choose these servers to be load balanced across, right? So I won't have to key in all the individual IP addresses or the DNS or the FQDN myself. Everything is integrated into the platform already.